A large magnitude 6.8 earthquake struck Japan earlier today, and while the strongest ground shaking it produced is still up for debate, there's the potential for two words that absolutely frighten me as a geologist: MMIX or MMI-10. Let me quickly tell you what this means. Structures designed to withstand strong earthquakes receive damage, some well-built wooden structures are destroyed, railroads bent, and most masonry and frame structures destroyed along with their foundations. The simulation in the background shows just how extreme this can be. While it is fully possible that the strongest ground motion only peaked at MMI-9 instead of 10, the potential for damage and casualties is nevertheless high, with the collapse of at least one bridge, a shrine, and parts of multiple structures reported. The earthquake in question struck at 4:26 p.m. local time on July 28, 2026, originating approximately 14 kilometers south of the city of Kumamoto on Japan's island of Kyushu. The only good news is that, despite representing the strongest ground motion from an earthquake to strike any part of Japan in 2.5 years, the earthquake only lasted for 15 seconds. If it had hypothetically lasted twice or 3 times as long, damage would have been far more extensive in my opinion. Thus, we are not seeing a Venezuela-like earthquake situation, especially due to the widespread adoption of earthquake-resistant building codes in Japan. Nevertheless, preliminary U.S. Geological Survey model estimates suggest a 50% chance that between 21 and 325 fatalities occurred, alongside a 50% chance of $723.1 million to $19 billion in damage. Once again, these estimates would likely have been far higher in both categories if not for Japan's very thorough earthquake building codes. But why did this earthquake strike, and why am I seeing mentions of both a magnitude 6.8 and a magnitude 7.1 earthquake? As for the latter question, there was only one earthquake, but different government institutions assigned it different magnitudes. The Japanese Meteorological Agency noted it was a magnitude 7.1, but the U.S. Geological Survey noted it as a magnitude 6.8. Either could be technically correct. The earthquake specifically struck on the Futagawa-Hinagu Fault Zone, which I have outlined in red here, with part of this fault forming a distinctive boundary marking the edge of mountains to the southeast of the local population centers. The earthquake was shallow, striking at 10 kilometers or 6.2 miles depth in the crust, and caused the fault to move in an almost purely horizontal manner, denoting a right lateral strike slip fault. It appears that a 36.5 kilometer or 22.7 mile long segment slipped during the earthquake, specifically by up to 2 meters or 6.6 feet. This extent is noteworthy because it seemingly occurred right at the very southern end, and thus essentially next to the extent that slipped during a larger magnitude 7.0 earthquake on the same fault system on April 16, 2016. So, additional strain may have been added to the more southern segment of the fault system in 2016, and this built up until causing today's earthquake. This fault zone is part of the broader median tectonic zone, and its motion is mostly derived from the horizontal vector of oblique, ongoing subduction of the Philippine Sea Plate underneath the Amurian Plate. Already, at least 5 magnitude 4 range and 1 magnitude 5 range aftershocks have struck the vicinity. These aftershocks are most likely, in my opinion, to strike along portions of the aforementioned Futagawa-Hinagu Fault Zone. Stay tuned for more updates. A special thanks to this channel's patrons on Patreon and channel members on YouTube for supporting my work.